Hello, good morning. I'm Brenda Garcia from Mexico, and today I'm going to talk about introduction to product lifecycle. And I'm going to bring some of the topics, some key points, key questions that we're talking about yesterday with Carlo, with Rajani, with Ritu. There are some things that still have to be remembered or interwoven to understand all concepts, because this topic on product life cycle is particularly very focused in it has a short focus, but it's important not to lose the wider focus of everything of this inside a sustainable concept, in a broader concept. So sometimes we will zoom in some particular concepts, but it's important to consider still again the systemic focus, like the approach with a general view. So, well, these are the topics we're going to talk about today. I'm going to make some comments on some very fast, and in some other topics I'm going to be speaking a little bit more. But first I want to ask if anybody knows here, or have you, during your bachelor studies, for example, have you been, do you know, have you learned or studied about product life cycle? What do you know about product life cycle? Or it sounds like. Yes, you. What's your name? Shubi? Shubi.
Product life cycle describes about a product from where the raw material, from the starting to the end of a product. For example, if we take a pen, then the raw materials, the product life cycle starts from the raw material like plastic or the granules from which it we create to the manufacturing plant, how to manufacture, the places that it has been distributed for consumption, and after the consumption, what happens to the product.
Exactly. Very good, Ritu. Oh, what's your name? Sorry. Shubi. Sorry. Very good. Yeah. And do anyone has a similar idea or a different idea of this, a different concept, or do you agree with Shubi? Sorry, very Shubi. Do you agree with Shubi? Yes, more or less. Yeah. Okay. Well, yes, that's more or less the general concept. But why is it important to think in terms of product life cycle? Why or where do we have a reference, or why would it be important or valid to think in terms of life cycle? Well, in nature, for example, it's one of the basic principles of life. So we have a valid reference that there is a reason why we should consider or start thinking in cycles, not in linear processes. We have seen that in nature, for example, life has been evolving, and it has been for years and years and millenniums, and most of the reasons is also because it has cycles and cyclic processes. So why should we take that as reference and start thinking in cycles, right? And besides what Shubi, yes, okay. Besides what Shubi said, that it's there's something. Restart. No, don't say. Well, while it's restarting PowerPoint, not only why we should be thinking in terms of cyclic processes, cyclic, yes, but also what happens in these cycles. For example, Shubi told us about a pen, for example, no? That from the extraction of materials, and then the process, and then how is it probably could be disposed of or recycled. If it's disposed, then probably it won't be a cycle. It will only be like a linear process because nothing will happen afterward. Maybe a biological process will take a lot of time so that these materials will degrade into the land and then could be used as material, raw material again, but that would be like 100 years afterwards. Maybe in that way the cycle would be closed, but actually it's like, it would be like a linear process, not really a cycle. So that's one point. The other point is to consider that the pen itself, for example, if somebody says, this is the sustainable, super sustainable pen, it's not only, it doesn't depend on the pen itself. Even if you talk about a material, many of my students sometimes when we are working in a project and they say, oh, my chair is sustainable. Oh, really? Why? Oh, because it's made of bamboo. Okay. The material itself, even if it's made of bamboo, it doesn't mean it's sustainable. It's not, it doesn't lie on the material itself or the product itself. It has to do with what happens during the whole life cycle. So it can be made of bamboo, but if it comes all the way from China to Mexico, and how was it manufactured, and maybe there was a lot of water usage and a lot of energy, it doesn't matter if it's made out of bamboo. The material itself or the product itself, it's not sustainable by itself. So in this life cycle thinking, we have to consider also that products alone do not pollute. It's the processes inside them, the transport that takes them from one point to another, the way it is used, the incinerator that burns them, or the way they are degraded into the land, etc. So that's why we can see here, this is a diagram, like very simple diagram. I normally use it so to make more or less clear what are the phases of or stages of a life cycle. But actually this is in real life a lot more complex. There are like mini cycles inside some of the phases, but just to put it like in a simple way, this would be more or less a life cycle of a product, for example. No? So it would start, you said, for example, that it could start in the raw material extraction, but also it's very important to consider the design phase, because that's where everything is stated or determined. It will determine if it's a pen, or maybe it's not a pen, maybe it's something else like a grinding, whatever, another thing, right? So it all starts with the design, then the raw material extraction, we're going to talk a little bit further about this, then manufacture, distribution, use, end of life. And if a product only, if it ends there in the disposal, it's not really a cycle, it's a line. It's a linear process. We couldn't be talking about a cycle if it ends after it's discarded, for example. Just if there's a way or there's a process that could continue and starts again with a material extraction of raw material extraction, then we could talk about, okay, the cycle is really getting close to a circle. So now it could be a cycle. If not, it's not a cycle, it's a line. And it's important not to be designing lines anymore. We have to start designing cycles. So far, at the universities, we are taught to design normally from birth, from cradle to grave. We are not, well, at least in Mexico, there are not many efforts to teach students, for example, to design cycles, to decide how to make the products again born or reborn, but it's always the focus from the start to the end, how it would start or a product will get to life, and then how is it disposed, and that's it. Normally the focus is from cradle to grave, and that also is because it depends on the conditions. For example, this is a diagram that a student of mine made, and she was making a life cycle diagram of a ceramic, a potter, like a vase. And she said, well, for example, ceramic, it has like all these stages when furnace is used, troughs, water, then the second furnace, the second transport, then it's mold, then it's, I don't know, cold, and then it's used, you use transport, and then if it breaks, well, it's probably not going to be recycled or anything, and that's the end of life. So we could see that it's a linear process in this case, and in most ceramic products, the process would be linear, not really circular. It's not close to a cycle, but we can see the different stages there. And this is another example of another student, and I asked her to do a life cycle diagram of a chair, and it was also the same. It depends on the case, in each particular case, but normally, in general terms, the chairs wouldn't be recycled, or the cycle is not closed like naturally. Normally, there should be like something very well designed to allow that the cycle will close. If not, it for sure, or mostly for sure, it won't be closed like just naturally or without effort. It has to be designed, it has to be determined that how the cycle is going to close. If not, it's most probably that it's going to be a linear process. But here we can see everything from how on the wood is taken, if it's going to be by machine, mechanical machine or electric machine, and then if it's going to be like transported to another facility, and then if it has, for example, it has some welded elements or bolts or nails or another elements, everything, but it depends. This is a general case, but it depends in each particular case how all the elements in a cycle are changed. So, for example, so we have the life cycle, and there are different ways to close the cycle. If it's just discarded, as I said, it's more or less like or most likely to be a linear process. But there are some stages, there are different ways to close the cycle. And this also has to be designed. From the moment we are going to design or determine that it needs to be a pen, for example, in that same moment in the design phase, it should be determined how we are going to close the cycle. So it could be, for example, in a recycling mode or a way to close the loop, or maybe through remanufacture or through reuse, but each one of them are different levels or different ways to close the loop, to close the cycle. And they have all different impacts. It's not the same to close the cycle as recycling or to close it as reuse. Why? Why it's different? Normally, you would hear, at least in Mexico, like, okay, just make something, recycle, or just reuse it, whatever. But it looks like it's not the same. It's not the same to design a product to be recycled or to use it to be reused, for example. Why? Why, Marijan? What? Energy that it takes, for example, yeah. reused, and what kind of energy and where, if it's recycled, for example.
Maybe reuse is recycling is building materials, so
Uh-huh.
she would be in say melting.
Exactly. If it's recycling, you have to go like 5 steps. You have to repeat your back to square number 1, and again repeat an industrial process. Again trucks. Again fábricas, how do they? Manufacturing plants. Again water, energy. There are again scraps. Again packaging. Again more trucks. You have to repeat an industrial process again. And it's, for example, it's different as if it's reused. The product itself, it doesn't go anywhere. It doesn't, well, normally, it doesn't go again to a manufacturing plant. It stays with the final user. And then with you, there are no, unless you have like a manufacturing plant in your house or whatever, but normally it wouldn't take much energy or water to make again the product useful. It will stay in with the user. So it's different. There are different stages or different impacts in closing the loop. If you go back all the way to have a raw material and start again a complete industrial process, then would be recycling. And that's an important thing because, at least in our context, there are many misunderstandings. There are words used. If it's reuse or recycling, we just say recycling as if it was synonym, but it's not the same. It's not the same to reuse or to recycle. Recycling, it's always an industrial process to have the material, the waste material, again turn into raw material. But it has to go through an industrial process again. That's recycle. And then you have remanufacture or reuse. So once we have already we have observed, we have understand what are the phases in this cycle. That's one thing. We have already then we have a life cycle thinking. Okay, now I understand all the phases that a product goes through, and if it's closed, then it's called a cycle. Okay, that's one step. The other step to really get to understand or get a life cycle thinking is to understand that what goes in and what goes out, like inputs and outputs, in each one of the phases of a life cycle. For example, since the material extraction, there are inputs and outputs in manufacturing. It's also like different inputs and outputs, etc. In each one of them, there's something going on. So when there is somebody saying that, oh, this is super ecological, it has no impact at all, it's almost impossible. There's some kind of impact. Even if it's recycled, even if it's biodegradable or whatever, I see there are some metal parts of this. So it means that somewhere, maybe there was dynamite used to explode a mountain to get the metals, and then etc., etc. So there is always some impact, some process going in and process going out in each one of these phases. Until here, is there any doubt or questions or comments? No? Okay. Then once we have observed each phase and how inputs and outputs come from each one of these phases, now we can realize that next time we start from the design process, it's much better to think in not thinking on designing pens, for example, or for example this kind of equipment, but what about designing the life cycle? What can we do to design the life cycle, not the product? What could change in the design process if we start thinking on designing life cycles, not processes? Well, everything changes. The many ways to see this will change. So, for example, if we go back to the example of recycling, if you see here, for example, in the reuse, remanufacture, and recycling, I wrote in these parentheses some little letters. Do you know what's that about? For example, in recycling, why is it DFR? Yes, very good, exactly. So there are some specific strategies from design that will tackle, for example, specific things like recycling. So there are, and this comes from, if I'm not wrong, from engineering, there are a complete methodology called design for X, and the X is substituted by the thing you want to change or to focus on. For example, so instead of DFX, it's DFR, so it's design for recycling. But there's also design for remanufacturing, design for, and there are many, there are like hundreds of these options. So there are specific strategies if you want to design a cycle to allow the product to be remanufactured, for example. So you have different choices to start designing the cycle, not the product, to think about all the stages involved in the cycle. For example, if we start with design for recycling, you would have to take into consideration many things. If I would like this pen to be recycled, first I want to think about, okay, how many parts or how many components does this pen has? Okay, it has maybe a cap, it has a metallic point and a tubular made of plastic, and then an outer shell of plastic. So we have already there like 5 components with probably 6 different materials, plus the ink, right? So what are you going to recycle? The cap, the ball pen, only the metal parts? What are you going to recycle? You have to consider, for example, how many materials. Is it easy to disassembly? It's very, then it will be like very little parts. Who is going at the end of life of the pen, for example, it comes into I don't know if there's like a municipal waste management. Who is going to take the pen to disassemble every part and say, okay, this is recyclable? Probably nobody. So how are you going to recycle or to design this pen so that it can be recycled? And what parts? What is the value of this plastic, for example? How many rupees are going to be, if it's like possible to have, if this material has a value, or nobody will care about it because it's very cheap. Everything, all this has to be considered if I want to design the pen to be recycled. And also, it's in Mexico, for example, it's very common to see these marketing like labels in the products, and it says it's recyclable, and everybody buys it because it's like, oh yeah, it's super ecological because it's recyclable, right? But then if you want to like look further or research a little bit, okay, how this brand is going to manage the recycling process of this product, and it turns out that the company, it only says like, oh, this could be recyclable, right? Technically, it's recyclable because the plastic could be recycled. But my company, it's not doing any effort to go to the, I don't know if it's like a plant or at the end of in the landfill, and my company is not going to rescue all of these products, and we don't have a recycling plant or any processes to really secure or really assure that it's going to be recycled or recycled. So if a product if we want to make it recyclable, we have to design it. We have to really figure out how it's going to be recycled, who is going to recycle, who is going to pay for that material, for that separation of materials and everything. If we just suppose that somebody could recycle, probably it's not going to be recycled. So it's not enough to see a label that says, oh, it's a recyclable material, but if it's not designed how it's going to be recycled, it's probably not going to be recycled. Okay, so that has to be considered. It has to be designed from the beginning. Also, this is another way to close it. It's a remanufacture. and it doesn't go all the way back to the raw material. It just goes all the way back to manufacturing. And this is very useful when products are being leased or rented. And if we remember a little bit of what Carlo was saying yesterday, of some examples, how all these can fit into a wider perspective of SPSS when products are leased or rented, this also has to be considered. And for example, if we have medical equipment, for example, or laboratory equipment, and the client just wants to, it would be very expensive to buy it, so they rent it, and maybe for 2 years. So after these 2 years, maybe some companies, not the whole thing, just some companies, maybe some wheels or maybe some mechanical parts need to be changed, then it goes back again to a manufacturing plant probably, and some parts are taken away, maybe they are cleaned or freshened up or whatever, or changed to a completely new one, then they put them again, and it's again ready to be leased again. Maybe to a different client, maybe to the same client, but then, but it has to be designed for that, to allow some parts to be like cleaned or refurbished or whatever. It has to be designed. If, for example, some parts of metallic parts are welded, it will be impossible to disassembly so that it can be changed, for example. So that could be one consideration, for example. And also you have to design or think about how many cycles, how many times will be leased or rented, right? So that's another way to close the loop. But what happens when it's not designed? When, for example, in Mexico we have this platform, it's getting a little bit popular. So their new role of a prosumer, have you heard about the prosumers? Yes, Ravi. What is a prosumer?
Producer and consumer
when the consumer, it's also the producer, right? But here, in this case, for example, there's in this platform, if I own a bicycle, I can go to this platform and rent it or lease it, and then I can decide to which customers I can rent it and etc. But it's not really, it was not designed in the first place. It's just that I have a bicycle, I bought a bicycle, and then I rent it to you, for example. But probably this bicycle was not designed in the first place. So maybe it doesn't consider parts to be interchangeable and to be again refurbished or whatever to allow many cycles of renting. So it has to be from the beginning designed. If it was to be remanufactured or rented, it needs to take into consideration to allow this cycle to properly work. And we have another, now we are closing the loop in the last stage. Normally, in this stage, the final product ends with the end user. It doesn't go back to any manufacturing plant. It stays with the user. And normally the user, after using, for example, in this case, after using this envelope as envelope, you can use then as in this example is how do you call it? Hanger? A hanger. But it was designed. So the designer thought, okay, the first life of this product will be an envelope, and I'm designing the folds in this way that, and with this thickness of the material, etc., so that it can work as a hanger afterwards. It has to be designed. It was not something that the final user just thought of, oh yeah, I can do a hanger with it. It was designed, right? Also like the other example, it was designed the second life of this product. So that really allows and really controls better the way it's closed. But what is happening? Sometimes, and this is something happening a lot in Mexico, and I think it's very dangerous. because that's what people understand as recycling. First of all, it's not recycled, it would be reused because it doesn't go through an industrial process. It's with the final user, they would just do some final touches and then it comes out as a different product. And this is known as even in kindergartens or elementary schools or even in the outside public spaces. These are told to be good things to do for the ecological purpose. So everybody said like, oh, yeah, do this to save the planet, right? Recycle, please, convert all your bottles to other things. And every time I see that, it's like, no, don't do that anymore. I think that's very dangerous. First, because, in taking, like from a very objective view, this was not designed. Firstly, it depends on the final user's creativity. If the final user has good abilities with the knife and with the glue, and it depends on what he thought or what he saw in Pinterest, but it depends on the creativity of the final user. It was not designed to be saving, what do you call that? Yes, that. It was designed to be a bottle. That's it. It was not designed to be something else, right? So somebody thought like it would be a good idea to, at the end of being a water bottle or whatever, to cut it and to paint it and glue it and put some eyes and now you have a very nice, well, depending on your skills. I've tried to do some of these things, and well, even if I'm an industrial designer, it doesn't end up very nice. So at the end, what happens is the dangerous part, because even if you have super abilities and you have a super beautiful piggy, at the end, eventually it will get into a landfill. Eventually you will throw it away. Eventually. But then, when you throw it away, two things happen. One is that this piggy, it's not qualified to go into the recycling system anymore. The bottle is caught, it's not in the proper conditions because it's already with painting and everything. So this bottle is not going to a recycling clean process anymore. So its only destination is the landfill. But if it wouldn't have any paint or anything, the bottle would go to the landfill like in just with a plastic, as a plastic bottle. So the landfill would take some time to absorb and to process this plastic, and in some years, in a lot of years, then it would like go into the ground and degrade and like that. But now if it comes with ice and painting and glue, it comes like a bomb. It comes like with many more toxic charge. It doesn't come in a clean plastic way anymore. It comes with a very toxic charge to the ground. And now the ground will take more time and it will be more toxic to absorb this into the ground. So that happens when it's not designed. A second life or a way to close the loop is not designed. And then it's taken into an open destination to see if what the final user could do with it, and let's see what can do, but what the final user can do is these things, and this is very, very dangerous. So until here, it's any question or comments? Do you also do this, like in kindergartens yes? Like, oh, it's Mother's Day, so let's do some ecological things. And it's like, yes? Thank you. Creo que lo toco para
No, problemas conectar.
Bueno. So, talking about the starting point of the life cycle, that's why all starts in design, right? What would it have happened if this plastic bottle would be from the beginning designed to be with another efficient way to close the loop, for example. So it all starts with a lifetime optimization in the design. New solutions, when you start again about, well, what was the purpose? What was the functional unit? What was the need of this product? Then when all the innovation can also begin, right? Because you can have radical change. For example, if we go back to the example of the water bottle, and sometimes it's thought in terms of a water bottle, right? So how can we design a water bottle so that it has less impact? Well, the most probably thing that will happen is that it will stay as a water bottle, right? It's like, okay, we can redesign the water bottle and it can have different sizes, or the label can be with different colors, or now the cap could be recycled, but we are still stuck with the water bottle. What if we go back and again think about, well, what was the need? In Mexico, for example, everybody buys water bottles because it's not very safe to drink out of the tap water. So that's why we buy water bottles, right? But if we saw it from a sustainable point of view, yeah, Mexico doesn't need water bottles anymore. We have enough water bottles, and people they don't want water bottles, they want to drink safe water. So maybe designing better, higher, smaller, bigger water bottles, it's not really going into the root of the problem. What is the problem? So if we go really back to the root of the need, well, people need to drink safe water, or they want to drink safe water. Then the complete concept is changed. So maybe we don't end up designing water bottles, we end up designing a complete system. Because now, as Carlos said yesterday, for example, it's not about the product, it's the access to that need. So in this case, what could be designed to give access to safe water? So maybe it's not a water bottle. What can we design to bring access to safe water? So maybe now it changes completely, and we have to design a system made out of services. Maybe there are some other products, but maybe we even have to talk with the government for, hey, what are you doing with our water systems and things like that, right? So radical concepts change when we really think about what was the original need. And now it's ridiculous if you really think that, well, if the original need was to drink safe water, and it ends up with a ridiculous pink pig made of paint and everything. What happened there? The design process, something was failing during the design process. So here, the next topic is about case studies on sustainability-based LCA assessment, life cycle assessment, product life cycle assessment. Well, here we have an example of what happens when we take a look to product life cycle, or to life cycle assessment to, for example, in this case, our diapers are an incontinence product. In this case, there have been many reports and also many improvements regarding the product itself and regarding the environmental improvements of the products. For example, now the kind of treatment that the cotton has, or the efficiency of the glue used, or now the plastic, it's less, weighs less, and it's lighter. So there have been many environmental proofs. You can see lots of articles about that. But the interesting part is when we talk about sustainability based on product life cycle assessment, that's something different. Talking about environmental aspects of product life cycle, it's regarding the environmental impacts, energy, water, etc. But when we talk about sustainability aspects, that's a different thing, right? Because when we talk about sustainability, then we have to consider not only environmental aspects, but what we talked about yesterday. Sustainability has to do with what are we doing with our development ideals so that it can be sustained for generations. In what products are it's valuable to keep working, or maybe we have to think again what needs really need to be tackled, which needs are not really needs, what is important according to what context, right? So in this case, for example, they said that these kind of products really improve some people's quality of life. People that have incontinence problems, for example, it really helps in their quality of life, okay? But now it comes all these sustainability aspects, the social, the economical aspects of sustainability that tends to be tricky. For example, we can then think about what we were talking a little bit yesterday, quality of life. Well, it depends. These products could be really improving quality of life in some contexts, but if in other contexts, probably not. It depends on the needs in different contexts. It's not general for everybody. So life cycle assessment, even if it's more or less general for everybody, we really have to think about the sustainable aspect to see what fits and what doesn't really fit in a context. For example, quality of life, and sometimes quality of life is related to, at the end of the question is, well, maybe it's happiness. Quality of life, it's about being happy. Oh, if it's like that, we look at this chart and, well, India and Mexico, we are super happy. We are on the top of everybody else. We are happier than Germans. We are happier than Belgium and France and Poland. We're super happy. So what's the problem, right? But then all these sustainability aspects, social aspects are treated. Then I took a look to another chart where also happiness was there. And then it was like, oh, well, this is happiness, but happiness according to, so then happiness was explained why was somebody like qualified as happy. Oh, it was taken into consideration some aspects. For example, how do we, what's the name of it? For example, perception of corruption. How people perceive corruption in their context. Then Mexico, well, we were not happy anymore. We were like, okay, I'm automatically going to a lower stage, and also in this chart, happiness was perception of corruption, freedom to talk, freedom to do some choices, freedom of I don't know what, and overall health access, and then happiness was a little by little, right? Like coming down. So if we're going to talk about sustainability matters during a life cycle product, we have to take into consideration things like this. That's why in life cycle assessment, normally this is very difficult to take into consideration. How could we measure happiness and put it in the manufacturing stage of the product cycle or in the use? It's very complicated. That's why normally during a life cycle assessment, normally we just stay with the environmental aspects, because these are easier to measure, to be weighed, and to really say, okay, it's toxic or it's not toxic. But it's very different than to say it's happy or it's not happy. It's quality of life or it's not quality. It's very complicated. So we stay in with the environmental aspects when talking about life cycle assessment, at least at this point. So when we talk about environmental aspects, we have to consider first if it's a complete cycle or if it's a line, then how many stages are in this, or what are all the elements involved in each one of these phases, and also what comes in and what comes out, and how does this happen in each one of these stages. Until here, some questions? No? Okay. So we continue, and so that's why environmental impacts, they can be measured, they can be verified, they can be proved. So there's no excuse anymore to labels. In Mexico happens a lot. We don't have yet official, well, we're working on that, to have an official eco-label. Right now, until now, all the environmental communication they are not official. If you see a product that says, oh, environmentally friendly, that's not official, and that's mostly just a happy face in a tree, but that's it. It's a happy face in a tree, and it's very difficult to really, if with a life cycle thinking like this, life cycle assessment approach, it's very difficult to say it's environmentally friendly. Where after seeing all this, it's ridiculous to call a product environmentally friendly. Friendly to whom? To what? Because I waste a little bit more or less water, now I'm environmentally friendly according to what standard? So all this starts to be ridiculous, and only the things that can be proved, can be measured, then it's valid to say, okay, it's less, the impact is less because related with this, and it has to be really like measured and valid. So a little example. Oh, something happened here. Well, it all starts with the function, the need. What was the need? This is in order to know how am I going to do my life cycle assessment of what and which other products can I compare. So it all starts with deciding what's the functional unit. For example, in this case, it's not the same saying I'm going to do the life cycle assessment of a cup and with a thermal or another, because it's not equivalent. To know if it's equivalent or if it's comparable, it has to do with the functional unit. In this case, what is the functional unit of all these 4 cups? Their functional unit, for example, is to contain 250 milliliters of hot liquids during 2 hours. If they tackle this same function, then yeah, they are comparable. They are in the same category. So we have different types. We have plastic cups, we have glass cups, all of these like fulfill or have the target to fulfill the same functional unit. So we take into consideration all these 4 products, and we can also go with each one of them through the life cycle in each phase, what resources, what kind of energy, what water, what everything, what all inputs and outputs were into each phase, and then at the end say, okay, maybe the plastic cup has less impact than the glass one. But only if we go through every phase and measure everything, until then we can really, really say which one has less impact. Sometimes it happens that just to see, you can say, oh, I think the glass one is more ecological. It has less impact. But sometimes that could be deceiving. That maybe that's not always the case. For example, there are many articles that talks about diapers, disposable diapers and cloth diapers, and everybody says, well, the cloth diapers, of course they are more ecological. But until you really measure, and it depends in each different context and each different case, it can vary a lot. It depends if the mother, for example, if she has 4 diaper clothes for the kid, or maybe she has 40, so maybe she has to use the washing machine once a week or every day. And if it's cloudy, so maybe she has to use a dryer also. And if she puts also like detergent and other things, it depends in each case. And sometimes it can be that disposable diapers has less impact than clothes. Depends. and it depends on the category of the impacts. In the diaper, cloth diaper, we're talking more about water use. The impact is in the use phase. And the disposables are more when you dispose of it. So there are different ways of polluting or impacts. One is it more with the water and the energy used, and the other one it's more about when it comes into the landfill. So there are different impacts. They are not really even comparable. So what are if I want to do a life cycle assessment, where do I start? What do I start doing, or what's the first step to take? Bridget.
See if the product is necessary.
Okay, the needs? Yeah.
Do we really need to have a barbecue grill in this way?
Yes, but well, that would be when you want to redesign or design something to maybe cook your meal or whatever. But if you really want to do a life cycle assessment of this product, where would you start?
Would that include deciding whether this need is actually a need?
Yes, that's when you want to design and say, well, maybe we don't need this. We can change into the service probably or whatever. Yeah, but once you have it and you are really want to do a life cycle assessment, analysis of where does the impact goes, where do you start?
What is the context?
Aha, very good. Where is the context? What else? Ravi, you were going to.
Manufacturing process for each of the products that you want to assess.
Yes. Well, that's a second level. First, you would like to first define what are the objectives. Why would you like to do a study like this, an analysis of the impacts? If it's going to be because you want a certification, or maybe just to have two comparable versions of your design, or to communicate it with a label, why? What do you want to do with this assessment? And what is your scope? It's only, for example, talking about the pen that Shubin said. For example, then you define, I'm the producer of the pen. My assessment will only include the pen, not the packaging, not just the pen, for example. And also, well, and that's like the objective. And why? Maybe I want a certification for my pens, or maybe I just want a very fast comparison to know what other type of pen can I design. It depends. Then, after you have decided the objective, you start the analysis. You start to see each one of the phases of the life cycle, and then, like Ravi said, for example, take a look in the manufacturing phase, in each one of each one of the phases, and what happens in each one of these stages. For example, in the manufacturing, how was the cap extruded? Was it plastic? In what manufacturing plant, with what energy? Was water used? Was there discarded extra material? What happened in the manufacturing process, for example? And then in the distribution, does the caps were produced inside this manufacturing plant, or it comes all the way from Singapore, or everything related to all the way to the disposal? Or if you have already, for example, a recycling process, you should also consider the recycling process. So the whole life cycle is like analyzed, and then after you have all the information, you know what water was used, how much, how many kilograms of everything. Now that you have all this data, then you evaluate the impacts. And this is very tricky sometimes because it's like the diaper case. Sometimes you end up having results in terms of, okay, this design, this cloth diaper, its most impact is the water used in the washing machine when all its use. And this disposable diaper, The highest impact is maybe in when a mother puts it inside a plastic bag and ties it and throw it away. Maybe that's the most critical impact. Okay, in terms of design, what do I do with that information? If the result comes in terms of carbon dioxide that was emissions from the disposal, okay? What do I do in terms of design? So that's a very key part of the life cycle assessment, the interpretation and improvement analysis. What do I do with that data? What in terms of design? So sometimes when you are developing this kind of analysis, you have like these kind of diagrams. Normally they are much more complex. These are really simplified processes of what happens next in what phase, etc. Very, very simplified. And then you can have like ideas of, okay, the biggest impact is in this phase and in this phase. For example, if it was about the glass cup, for example, it's just an example, one of the biggest impacts is in the manufacturing phase and in the usage phase, because it has to be clean and it breaks and blah, blah, blah. Okay, now I know where the most impacts come from. Now, how do I redesign? What do I take? And then we can do, as Ranjani said, then we can decide whether you go all the way back and really think about, well, do we need a cup? Or maybe we don't need a cup. What do we need, right? Because so far the functional unit is to contain 250 milliliters of hot liquids during 2 hours. But what if we change the perception, the question, in terms more of SPSS, like Carlo was saying yesterday? What if the question is how to have access to 250 milliliters? So everything changes. So maybe it's not a cup. Maybe it's a system where you go and open a machine. I don't know. No? Then you have an opportunity for SPSS design. You can have a broader concept. Thank you.